How do you create a habit of reuse instead of making new stuff? Hi, my name is Eric Normand, and these are my thoughts on functional programming. So in functional programming, at least the way I'm used to seeing it, we tend to reuse pieces a lot more than in typical object-oriented programming. Why is that? Well, I don't think it has anything to do with the paradigm or the language. I think it has a lot more to do with the habits that the programmers have in those various communities. And I'll give an example. Actually, Rich Hickey gives a really good talk where he's talking about how in the Java world there's a thing called servlets, and the servlet defines how to process an HTTP request. And so there's a class called HttpRequest, something like that, and it defines all the stuff that you would expect in an HTTP request. And he puts the slide up and he asks, so the slide has all the methods in the class, just their signatures, and it's pretty clear what they do. They're well named, but he says, what are the hash maps? Where are all the hash maps? And it's kind of a weird question. You're not used to asking that, but some things are pretty clearly hash mappy, right? Like there was a method called getHeader, and it took a string and it returned a string, right? So it's kind of like getting out of a hash map, right? It's got a key and a value. And then there was also like getProperty, and you would pass in a string and get a string back. And if you could do like getProperty names, and it would give you a list of all of the property names that were defined on that request. So you could see, yeah, these are hash maps. Why did they define their own custom little protocol for that? And then he was like, but look, there's actually deeper hash maps that you don't think about, because all of these other things that are just defined methods on the class, they're just getters. So they're just like stuff like get port and get host, get IP, right? And so why not just make those those are just the keys, the IP, the host, the port. So those should be, the whole thing should be a hash map, and these are the keys. And what he was getting at was that in Clojure we have this thing called ring that defines the hash map format for representing an HTTP request. And that's really cool, because it means that you don't need a new type. You just need this new spec for what goes into the hash map. And everyone already knows how to use a hash map. I mean, if you're a Clojure programmer, you're using hash maps, and there's all sorts of functions for dealing with them already, and they can be serialized. And basically we're getting all this reuse out of hash maps, when in Java they have hash maps. They could have done that, but instead they chose to define a new class that required more documentation. It required re-implementing a lot of this functionality. Like maybe it even uses the hash map internally to represent those headers. It might. And so the whole point was that in Clojure, this is what we do. We reuse. It looks like a hash map. Just use a hash map. Why would you create a new type just for that? And in Java, they don't do that. So to me, it's just a habit. It's just a habit. Now, how do you develop that habit? That was the question I started with. Well, the habit is really about understanding the two parts, right? You have to understand, number one, what you've got already. What are the things you've got that you could reuse? So you've got to understand your data types. You got to know you got vectors, you got hash maps, you got sets, you got your sequence abstractions, you got all sorts of things that you got to learn and kind of have indexed, right? You have to have these data types indexed by their access patterns. So if you look at a thing and it says it's a get property and it takes a string and it returns a string, well, now you got to be thinking, wait, that's kind of a key value thing, and so that's probably a hash map, right? You have to have that automatically. The second thing that you have to be doing is just constantly be accessing that index. So instead of thinking, so instead of thinking, what new thing do I need to make, you should be thinking, what thing can I be reusing? And so then you start to look at the thing in terms of these access patterns. Okay, the access patterns are going to depend on the language. Clojure defines a number of them. They're kind of standard interfaces that come with the language. They include stuff like the sequence abstraction, which is how you access items one at a time. There's whether you're going to be remembering duplicates, that's an access pattern. There's accessing a value given the key. There's adding stuff to a collection. Where are you going to add it? Are you going to add it to the front or the back? If it maintains order, these are all the types of things you have to be thinking about your data structures. So you can't just think of unfortunately, I was taught this way, that like a list, that's just an ordered collection, right? But it's not quite, right? To think of it that way is missing a little bit of the important information. So I was taught Java, and look, you have a list interface, and it has these methods on it. And one of the methods is like get, and you give it an index, an integer, and it'll give you the item at that index, which sounds reasonable, right? But the problem is that when you implement that interface, a get might change algorithmic complexity, right? So if you have an array list, which is another type in Java, if you have an array list, it can quickly give you the value based on the index because it's implemented with a big array. And arrays can do that. You have random access into the array. But if you use the linked list, which is another type in Java, another class, then you can't do that. You have to actually iterate through the list, counting how many you've seen, and then return the last one, the one at that index. So it's linear as the list gets bigger. So to say that they are sort of both implementing the same interface is kind of a lie, okay? Because your algorithm could go from constant time to linear, or worse, it could go from linear to quadratic. It's accidentally quadratic, just because you didn't realize that was going to be accessed, right? And so what Clojure has done is, to a large extent, it's not perfect at this, because you can still get an element at an index. It just uses a different function from get, right? So if you're in a linked list, you can do nth, but nth is known to be potentially, linear, whereas get on a list doesn't work. But get on a vector does work, right? Because it's constant time. And so these operations, part of the contract is that they maintain algorithmic complexity. So when you implement those interfaces, part of the contract is you shouldn't be implementing this if you cannot be constant time. Okay? So those, and like I said, it's to a large extent, it's like 90% this is true. There are some exceptions, and they're unfortunate, but to a large extent, I believe that Clojure does it right, and that these are the things you need to be thinking about if you're a programmer, right? You're doing anything at any kind of reasonable scale, you have to start thinking about the algorithmic complexity, and it should be part of the interface. And so those are the things that need to be sort of the first choice you make. How am I going to access this stuff, right? And then, of course, that leads to this kind of reuse. Why re-implement a hash map or even wrap it up if I'm going to have to define all these new methods? And I mean, why not just use what's already there? All right. My name is Eric Normand, and you can reach me on Twitter. I'm at Eric Normand with a D. And you can also email me, eric@lispcast.com. And I hope to hear from you because I love getting into discussions with people. Awesome. Rock on.